Hey, my name's Gabriella Olivo. I'm in group 9 and I'm going to show you my midterm project. So share sound, share my PowerPoint. Let's go into full screen mode. Okay, make sure I'm sharing my new screen. Okay, so here I have we built a continuous digital thermometer with a GUI interface. It's spring 2022. Move this out the way here. So the objectives set forth were to collect data for more than 1 minute, no more than 5 minutes, with a sampling rate that needs to be faster than 1 per second. I did half a second sampling rates. We'll need to see the temperature increase above a threshold and bring it down below the threshold. When we raise the temperature, it should plateau and hold steady. And same thing for the cold temperature. The x-axis should represent the appropriate limits. And your data plot should represent your sampling time. Your GUI should be able to run with until the stop button is pressed, regardless of total recording time. And I'll show you that we met all of those objectives in the next 2 videos. Okay, so I'm going to go ahead and play this video, which is the GUI functionality. Hey, my name's Gabriella Olivo. I'm in group 9, and I'm going to tell you about my GUI for the midterm. Okay, so I'm going to share my screen. I'm going to share MATLAB. Okay, so here's a quick breakdown of my GUI. I have a few components, image, title, a plot that's going to show time versus temperature from the temperature sensor connected to the Arduino. We have a temperature alert lamp that's going to change to either pink, green, or purple based on if the temperature is cold, room temperature, or hot from the set 75 to 80 degree threshold. We also have a current temperature text field and an average temperature text field that will display after selecting stop. And here's a current temperature gauge. So I'm going to go ahead and run the software. And I'm going to share my new screen of my software. Okay, so right now, let me move myself on my line. Okay, so here we have the temperature alert as blue. That means that the Arduino is ready to start collecting data. Everything's connected properly. So I'm going to hit start, and it immediately turned to pink because it's below the threshold. And we can see we'll let this run for about 20 seconds, and after that we'll heat it up a little bit and go through the different stages. So I have my temperature plotting in half-second intervals, so we're getting plenty of data points to go off of here. Okay, looks like we were steady at the cold for about 20 seconds. I'm going to go ahead and heat up. Right now we're in room temperature mode, and there is the hot temperature. And we're going to let this run for about 20 seconds too. And all I did was use a blow dryer to heat up the temperature sensor. We could see the gauge moving accordingly, live temperature readouts, and everything is functioning as normal. We also have a couple different buttons here. So we have the start, as you guys know. We have the clear, which will just clear the data plot. We can hit start again. I'll start collecting data again. And the last functionality here, we have the stop button, which will break the Arduino connection and also show the average temperature. Okay, so we have the average temperature update. It cleared the plot, and we could just hit start again, and the plot will start all over again. So we can see that this GUI has met all the functionality points set forth in the midterm lab. Thank you. Okay, we're now going to move on to the Arduino Uno physical LED video. Now I'll just break down the physical setup. Hi, my name's Gabriella Olivo, and I'm in group 9. I'm going to show you my midterm project. Here we have the MATLAB GUI that we already went over in detail. This was created in MATLAB's App Designer. It has a live temperature alert that will change colors based off if the temperature sensor is picking up environmental data that is either below or above the temperature threshold. Right now, the temperature is within the threshold, so it's green, and that's going to correspond to the LED not being on. So that means everything's good. So when the temperature threshold is either below or above, that the lamp will turn pink or purple, and then this LED, physical LED, will also turn on. So I'm going to adjust the temperature and try to heat up the sensor. So you can see that the sensor just turned green, and over here we can also see that corresponds to the temperature alert turning purple, which means that that is hot, and that all corresponds with the live data readings we're getting from the plot. Thank you. Okay, and that concludes the midterm project for Group 9. Thanks.